Okay, continuing with 6.2, let's note that if I have tangent of tangent inverse of x, well, clearly that should be x, but this is for all values of x. Is there a restricted domain for the inverse tangent? Don't know. What's a domain of inverse tangent? Looks like it's all real numbers, right? Okay. So this is valid for x, any value of x. Okay. However, if I do, tangent inverse of tangent of x, well, that's x, but now I do have to restrict my domain. So because I'm evaluating regular tangent of x first, note that regular tangent of x has been bound between negative pi over 2 and pi over 2. So this is for all values of x between negative pi over 2 and pi over 2. Okay, so similarly, if I evaluate cotangent of cotangent inverse of x, well, that's x for all values of x between, well, the inverse function for cotangent is valid for all values of x. So all real numbers. However, if I take cotangent inverse of normal cotangent of x, that's only going to be x for x values of x on the restricted domain, which was from 0 to pi, non-inclusive. Okay, so that's x for all values between 0 and pi, not including the endpoints. So for example, so let's evaluate the following. Number 1, let's evaluate cotangent of cotangent inverse of negative 1. So we have cotangent of inverse cotangent of negative 1. Okay, so inverse cotangent, that's going to be this guy here. So my values of the input are all real numbers, so I'm okay there. Okay. So let me let me annotate that just for a moment. Negative 1 is a real number, so we're okay. So let's let y be cotangent inverse, the inside for a moment, of negative 1, why? Well, because I want to rewrite this without the inverse. So I claim that this is equivalent to negative 1 is normal cotangent of y. Okay. So cotangent of y being equal to negative 1 has an angle y equal to, well, I have to be between 0 and pi. Since it's negative, I claim I'm in quadrant 2. So what is the 45-degree reference angle in quadrant 2? That's 3 pi over 4. Okay, so therefore, coming back here, cotangent of inverse cotangent of negative 1, which we found to be 3 pi over 4. Cotangent of 3 pi over 4, well, that's negative 1 as it should be. Check mark. Okay, so number 2. What if we had arctangent of tangent of negative pi over 6? So hopefully we'll get negative pi over 6 back. Okay, so let's do arctan of regular tangent of negative pi over 6. So where am I allowed to have regular tangent if I'm dealing with the invertibles? Well, regular tangent between negative pi over 2 and pi over 2. So is that argument negative pi over 6 in the region it's allowed to be? It is. So negative pi over 6 is indeed between negative pi over 2 and positive pi over 2, so check mark. Okay, so what do we get? We get that arc tan of what's tangent of negative pi over 6? Well, I know that sine of negative pi over 6, or the 30-degree reference angle, is negative 1/2, divided by cosine is positive root 3 over 2, so I claim it's 1 over root 3 negative. Unrationalized. Okay, so let's call this guy y. Yellow y. This would be equivalent to writing negative 1 over root 3 unrationalized is equal to normal tangent of y. Remember, arc just means tangent inverse or inverse. So at what angle is that true? Well, that's true in quadrant 4. So y must be equal to negative pi over 6. Check mark. It does work. The inverse, the composition of a function with his inverse, always works.